Okay, so first we're going to look at an example for a basic movie database that violates some of the normal form principles if you're going to store this in a standard database table structure. And we're going to go over what a basic query to pull all the information would look like. And the big thing that we're going to hint on here that's hard to see until you try to run this query unless you're really good at SQL is that this causes a whole bunch of duplicate information and doesn't pull efficiently to kind of go through and get only the pieces that you want. If you were to throw this into an application, say, for a search or recommendation engine in order to do movies, you're probably going to be better off writing multiple separate queries. One to pull the basic movie information, one to get the genres for those movies, one to get the production companies for those movies, one to get the cast, one to get the crew, kind of, etc. So looking at this, hopefully most people can relate to how a movie would kind of be structured, at least conceptually. So we have a movie. There is information about that movie, such as the title, the description, release date, runtime. Those are very specific to the movie in general and the movie in question. You would think, unless you're thinking about databases, that the cast, the actors, every single movie has multiple actors in it. Now, the multiple piece is where you start running into issues with traditional databases. Because an actor has multiple characters because a movie has multiple characters played by multiple actors, you run into a many-to-many situation. In this case, what I'm showing here is we've kind of violated that principle. So the person ID, if we had a character like Scarlett Johansson that is played in multiple Marvel movies, her information, her name, Scarlett Johansson, and any other information about her will be duplicated in this cast table multiple times. Not a good way of storing data for a traditional database structure. And then on top of that, you're going to have multiple characters. So a movie has multiple characters in it, and each individual actor could play multiple characters in the same movie and definitely multiple characters in different movies. So that's kind of what you have here. Same thing with directors. As a general rule, a movie only has one director, but that is not always the case. Many movies have more than one director, so you have to have the directors in its own table as well. Now we get into genres. So this is more of the normal form if you're taking traditional databases and trying to normalize them as much as possible. We create this intermediary table that handles the many-to-many relationship, because a movie can be part of more than one genre. It could be an action genre, and it could be a science fiction genre, and it could potentially fall into a thriller genre as well. And then each individual genre has a specific name, and maybe it has some properties about that genre. And we don't want to duplicate that information across multiple movies, so it would be stored in its own table called genres, where you get the genre name. So this would only be the list of, say, the 25 genres total that we have for all movies that we classify everything into. While this one will be a table of all of the movie IDs to their individual genres that they're potentially part of. Production companies basically is situated the same way. So this is kind of a basic structure for something that violates normal form, but at least you can understand how you would want, say in an application, to display with a movie's information the list of actors and the characters that they're associated with, the list of directors' names, the list of genres that that movie is part of, the production companies that helped produce that movie. If you're looking at an IMDb page or any other movie page, you're probably going to have all of that information about the movie. So the initial thing is if you're storing this in a traditional database, not a document database and not a graph database, you're going to have multiple tables. And this is going to probably go into more detail than what you would want to do if you're not really familiar with SQL, but this is a basic query that could pull information from the movie's detail, the movie information, joined to a genre table, and joined to a production company connection table, as well as the production companies table. Also joined to the cast table and joined to the crew table. And in this case, we're just going to select one specific movie. So 18 in this particular database corresponds to the fifth element. And to do some filtering and to make this not be completely overwhelming, we're going to only pull the first 3 actors and only the director from the crew. So if we try and run this query, you may think that this is going to pull you all of the information that you want in a really easy to use manner. So let's take a look at what this result actually looks like. So here I've ran that particular query in pandas with a database that's set up pretty much how we had it structured before. So you'll notice here that there seems to be some weirdness going on. So if we ignore the genre section for now, we see that Bruce Willis is coming up multiple times, right? And then in this particular column, Columbia Pictures is showing up multiple times. But then we kind of seem to start over again with the next production company, and Bruce Willis shows up multiple times again, and so does Mila Jovanovic, and so does Gary Oldman. It's strange, right? But essentially what's going on here is the way that the table's doing this and the fact that we're left joining every single time is every time that we add a new field, the amount of specific entries for that field duplicates all of the information. So in this particular case, the fifth element is showing up in many genres, right? They're considering it fantasy, thriller, science fiction, action, adventure. And so every single time that there's a new record where we're joining this to the production company, it's going to duplicate fantasy, thriller, science fiction, action, adventure, and it just keeps duplicating that. Same thing for the actors' names. Every single time that we get a different actor, it's going to duplicate it again. And then for the crew, as long as we had more, which in this case, it looks like I pulled which is a good thing, looks like I pulled the director wrong. In this case, if there was a director, it would multiply it again, right? And so for our particular purposes, this is much harder to parse than how the APIs and how EdgeDB and how a lot of modern databases that are either dealing with documents or are dealing with APIs specifically and are dealing primarily with JSON as the new modern equivalent of delivering this information, they would summarize these up into nested fields. And it is really hard, in my opinion, to wrap your brain around nested fields, how to deal with nested fields, and even how to just read the JSON in general. But this is kind of the alternative, is you end up with this cluster of duplication that you've got to deal with on your own and try and understand, as well as there is a bandwidth issue here of how much you're multiplying the data. Even just pulling one movie, right, that should have limited information, we're talking about over 44 rows, and that's only the first 3 actors, right? And that's not even all of the duplicated information that we should have. So that's kind of the dilemma that we're running into, and I know that that's kind of hard to wrap your brain around. The other solution to this would be having a database call for each individual table interaction, right? And then you just return the results for the movie detailed information. You return the results for all of the individual actors. You return the results for all of the individual genres, etc., which is a way to approach this. But if you want all of that information on one page every single time, it could be really inefficient or really hard to deal with how to connect each one of those together on the front end as opposed to letting the back end database or whatever structure you're working with on the back end do that heavy lifting. So next, let's go take a look at a few of the JSON-like examples that you're going to get. And then finally, we're going to go in and look at the Yelp API specifically, and we're going to kind of detail how you could dissect the information about the API into understanding yourself how the data is structured. And then the final thing that we're going to do is in Python, just because it's easy to kind of throw it in Python and throw it out of Python, we're going to show you how to iterate through and deal with a very specific example and a very specific structure for the JSON in the document. Okay, the first piece that I want to look at here is if you get into a really bad situation and get kind of like the worst user experience of getting back this API information, or you've passed it through Python and you've just done a basic dump, this is like the worst that you're going to get it. So everything in here is on one individual line. And I know you can't really tell, but that's what these arrows mean, is literally it's just wrapping the text, but technically this is all one continuous line. It's not easy to read what's going on. It's not easy to see where each individual either list or dictionary or key value pair and array, where any of those separate or combined or end. You can't read it very well, right? And in a lot of cases, depending on what program you're using, this may just freak out your computer and it may not even let you open these types of files in a text editor or in something where you can even see what's going on. Okay, the second example is structured way better, but it's also a little bit weird in that this was one when I was trying to structure one of these outputs myself. This was the approach that I started taking. So you can see that it starts off as a overarching dictionary, and there's this field called movies. Now, the interesting part about this is that's all there is. Like, it doesn't actually necessarily make sense to have this be a dictionary when literally movies is the only thing that shows up. So now next, we've got a list or an array, right? But if we look at this particular one, within this list, we've got another list or array. So we've got nested arrays, nested lists. And the irony here is that we didn't need that, right? Because it doesn't actually add anything to the structure. And I know it's hard to tell, but it's basically every single internal array here just has one dictionary in it. And most of the reasons why you would want an array or a list is to list off multiples of these. And we're going to look at a better example of what this would probably look like. Now, this final structure is pretty valid. So if we were to just have a list of these dictionaries, this makes sense because this would be a particular movie with its title and its year. And then we could have a comma followed by the next movie, the next title, the next year. And so if this was just in an array and it was an array of dictionaries or an array of key value pairs, it's reasonably easy to kind of deal with and work through those things. So there's two examples. I'm going to just show you one more. Okay, so this final one that I'm showing you, it looks like it's structured poorly, right? And this one was an extract from the movie database of individual movie reviews. And so this one is one that we ended up getting it in one gigantic line, right? So I want to deal with this. It's actually in JSON, which is great because the one thing that Firefox browser does really well is to display JSON in a nice, friendly to use format for the most part. It could get too big and you could have issues with it in Firefox, but we're going to see what it looks like, and we're going to open this specifically with Firefox. Okay, we're loading it up into Firefox. You'll see it display poorly for a second, and then you can see that it gets into this more manageable structure. So I would kind of recommend that if you need to navigate and understand the structure, that using Firefox to do this navigation is not a bad way to do it. Filtering for the JSON is useful, although I feel like it's just better for you to almost navigate this way. So what this 0, 1, 2, 3, 4, 5, what this is showing is that this is an array or a list. So these are not dictionaries. So if you're going to loop through this, you're going to basically say 1 to the length of however many there are in the array, right? And if we open it, you'll see that inside of the first entry in the array, the first entry in the list, there's a dictionary. That's what these open and close brackets are. And so inside of this, we have an ID for the particular review that we're looking at. Or no, I think that this is the ID of the movie. Yes, this is the ID of the movie, which this is something you kind of have to interpret yourself when you're looking at the APIs, is what do each one of these things represent? So now if we open up that ID of that particular movie, we open it up, it's got reviews, okay? We can see that there's a number here again, so this means it's an array, a list of particular reviews. So this one only has one review, right? Because it's got 0 there. We open that up, okay. Within this particular review, there is 2 items here. Now if we open up the first item, we can see that this particular review has an author, it has a created at, it has an ID, it has an updated at, it has a particular URL that we could get to this one. And some of these arrows are misleading. I'll show you with the URL one. When you open up this one, it just expands it. So it's not saying that there's a subsection under this, but the author details is a subsection. So if we open that up, you can see that under author details, we now have a name, a username, an avatar path, and a rating for that particular author is what's going on here. So this seems really nasty because it is a whole bunch of things to go down. It is nested lists and arrays. It's nested dictionaries within those lists and arrays. And you have to figure out a way of how you're going to deal with that and understand what each one of these things means, right? So this particular review was written by this person. Now, if we open up one, this particular review was written by another person, right? And then this person's going to have details, and they're going to have a URL to that particular review. Okay, now if we go all the way back up to the top to the root of this system, let's go look at another review. So let's do 6. So this is related to a different movie, right? And this one also has reviews. It also only has 1. Now, under that, there is 4 particular reviews. And now we open it up, and this is the same structure as what we saw before with the first movie, is each one of those reviews will be reviewed by a particular person. That person has details about them that are going to be in another dictionary under them that's under author details. And then there's IDs, there's URLs, etc. for all of this. So this is kind of how I navigate. And you always want to think in terms of, is this a list of items that I just need to loop through? Or am I pulling out a specific field that has a key associated with it? Like in this case, if I wanted this particular item, I would want to call out the author at this point. But that author is under the 6th record in the overarching top highest level hierarchy. And then within that, we're looking for the reviews key. And under reviews, we want to pull out 0, the first item in the list. And then under that, we would go to the item list 2, which is actually the third item in the list, and then we want the author of that particular review is what we're pulling out, and that author's name or user ID would be R96SK. So I know that that's really hard to deal with, and this is one of the complaints and complexities of dealing with the APIs is they return it in this sort of nested structure. So this is kind of what we're going to deal with next is we're going to take this and we're going to look at what an API call would look at high level and how you could kind of analyze what particular pieces there are. And hopefully whatever site you're on has decent API documentation. A lot of them don't, and you might have to figure it out yourself. So let's go take a look at the Yelp API and kind of its documentation, at least for a small piece of the Yelp API. Okay, so here on the Yelp API section for developers, I'm looking specifically at the review endpoint. And everybody calls these APIs slightly different things. And if you're using GraphQL, you're going to kind of interact with it and have more control than some of the more generic APIs that you're using for other things. But you also lose some other capabilities of efficiency and other things. So you kind of have to play with which one of these things you're going to get. But let's take a look at the particular API call for Yelp Fusion, for business endpoints, and for the reviews for those particular business endpoints. So if we look up here and we see what type of request this is basically how you're going to get that particular JSON is you're going to provide a normal GET request to this particular address, and what you want to do is put in the ID of the particular business that you're searching for. So you might have to use another API call, like the business search API call, to be able to extract what the Yelp ID is so that you can feed that Yelp ID into this particular API call. And so once you do that, if you've done it correctly and have a valid ID, in theory, you're going to get this sort of response that will be returned to you in a JSON response. And here, let's look at the things high level first. So we've got a basic JSON opening. So this is going to lead straight into dictionaries. So we're not going to loop through individual items in this case. We're going to go straight into dictionaries. And within the first key, we have reviews. So let's stop there, high level. That's the reviews. Is there any other key that's at this highest level of structure? So if we scroll down, keeping in mind that they've kind of tabbed this over logically, the next one we get to is total. So total in this case says 3. And then the final thing that we get is possible languages. So this total, which is something that's very specific to each individual API and is probably called something else, or might be a paging like page 10, or might be total 50 of 100. It could be hard to understand what it is, but in this case, 3 means that this particular API found 3 reviews, and that's all the reviews it found. Possible languages, it looks like, is a list here. So that's what these brackets mean, is that we could have a comma-separated list. In this case, there's only one entry in the list, and it's English. Okay, now let's go back up and let's look at the reviews. So within reviews, you can see that we've got a bracket open. This means that we're getting into a list. So in this case, it's a list of dictionaries. So the first entry is this one. So this would be under reviews, the first item, which is usually 0, is how Python treats it, as the first item is the 0th item, right, in the list. will be this one. Then the first item, the one item in the list, will be this one. Then finally, the third/second final one will be this particular one. And then you can see we close the bracket, so we close out that list, and then we're done with the lists. Now within each one of these lists, in theory, most API calls should be very consistent and give you the same thing. If they're listing off multiple things within the same level, they should all have the exact same IDs. Even if an entry does not have a particular value for that ID, like if one of these did not have a rating, usually the rating field will show up, and this will just be blank, be null, be some other value that you may have to deal with when you're parsing. But almost always, they're usually good about having all of the keys that are available to you in each one of the entries in the list. So if we look at this, we've got ID. It just has a straight value. We've got rating. It has a straight value. User, this one's a little bit different, so let's skip that one for now. Text, straight value, it's super long. Time created, straight value, we may have to deal with date parsing in whatever system we're pulling this into. URL, straight value, so we can just pull those out explicitly. They're just going to be there, no problem. Okay, under user, this is leading us to a dictionary. So within user, you've got a nested dictionary. So you have user, and that user has an ID. That user has a profile URL. That user has an image URL, and that user has a name. And then we go down to the next one. The structure is exactly the same, right? And the same thing for the next one. So now the nice thing here is that this gives us all of the information that we need to be able to parse through in a loopable and programmable way. The problem is understanding kind of how to navigate this and getting used to navigating nested lists, nested dictionaries, and nested lists of dictionaries and dictionaries of lists. It's confusing. We'll work through it. So we're going to take a look at a specific example in Python. We're going to pull one of these in and we're going to see what we can do with it. Okay, we're going to go into this a little bit blind. Theoretically, you have already looked at the JSON file for what you're dealing with, so hopefully you're not as blind as what we're going into this, but you can go into it blind into Python. So the first thing that we're going to do is we're going to load up pandas, which in my opinion, even though pandas can load in JSON directly, it's probably easier dealing with the nested JSON situation that we're going to be dealing with in a Python dictionary as it is in just a straight dictionary. And then once you get to the flat version that you want, definitely dealing with the advanced features of pandas in a flat table is way easier to deal with than some of the list structures to deal with in normal Python. The next piece is JSON. So regardless of whether or not you end up using JSON, a lot of things like pandas will end up loading in the JSON module anyways. Regular expressions you probably won't need until you start doing some data manipulation, but there is a decent chance that somewhere in there you're going to need to strip some characters, define specific types of patterns, etc. So regular expressions is a good one to bring in. Time, I don't know that I'm going to be using, but if something is taking you a really long time, you can just Google really quickly how to determine how long each step is doing using the time module. That's what that would be used for. Glob, I don't know that we're going to get to in this tutorial, but that's what I would recommend you use if you've got multiple JSON files that you're trying to loop through that are a very similar structure. You can use glob to basically be like load in all of these files sequentially, loop through them all, and dump them all into one file. That's what that one's for. So let's load up these modules first. Okay, now that those are loaded in, we can get rid of that. We're going to just open a specific JSON file that I know is somewhat small, but still reasonably large enough that we've got a lot to deal with. And with this with statement, what it'll do is it will close this specific file as soon as it's done with the with. So when we get down to print data, it will close out of the file. And then JSON load is basically what you're going to do to take raw JSON, which is stored in the JSON file, and you're going to load it into basically a Python dictionary. Now, depending on what the JSON starts with, it may actually load it into a Python list, which will be a list of dictionaries or a list of lists where eventually there's a dictionary. So we're going to kind of show you how to figure out what you're dealing with and how to decide which way you need to loop through the data. So first of all, let's load in that file and let's print off and see what it looks like. Okay, and this is one of the first things that's really useful to see. So it looks nasty. It is very hard to see what is going on here, but we can see with these double brackets at the beginning that it's probably loading in as a list and not actually a dictionary. So it's a list of something. So if I do, if I print off the type of data, we're going to see what it tells me it is. And you'll see that it tells me it's a list, right? Now, if I was to print off data, so let's actually leave that for now. Let's make a new one. Let's print data. And since it's a list, we can just kind of select any one in here. I know that there's more than one. So we're going to select print the second record in our overall JSON data that we loaded. Okay, this still looks pretty nasty, right? There's still a lot here. But now we can also see that this is also a list. So now, if I'm scared of dealing with this, one of the easiest things that you could do is we could just take this first entry in data and we could put it into a new variable. So we could do data2 equals this. Okay, so now let's see what type of information is data2, what data type it is. So if we do print type data2, it's also a list, which we could tell because of the brackets, right? Okay, so now let's go down here and let's do data2 and let's return the first record from that. And let's print that off and see what that looks like, right? So the first record in data2, hey, this is looking a little bit more clean, maybe a little bit easier to deal with. But now we can see that we're dealing with these curly braces. So what that tells me is that data2, the first record in data2, first record in the list of data2, will be a dictionary. So if I go down here and we're going to get data3 basically, so we're going to do data3 is going to equal the first entry in data2. And now if we do the type of data3, we can see that now we're dealing with the dictionary. So if I take data3, and because it's a dictionary, I have to give it a key to return a value from it. So let's go ahead and let's look up here and let's see what would be a good key to use. And the key will be the entry, the text that is on the left side of the colon. And then you'll notice that multiple keys are separated by commas here. So let's return out let's return out the ID. So if we do data3 and we do, apparently I didn't copy it, and we do ID and we want to print this, we can see that that number corresponds to that right there, right? Now, if I didn't want to make these all separate variables, and I wanted to get to this particular entry on its own, straight from data, this is what I would do. So for getting data 2, we took data and we took the first record. Okay, now data 2, which is what's represented here now I took the first record. Oh, this is the second record because the first record starts at 0. So now if I take the first record of data 2, essentially is what I'm doing here. And now I'm basically looking at data 3. Data 3 has the ID field. So if we add in the ID field here last, now if I print this, we should get the exact same value as what we got before. And you'll notice we did. But this makes it easier for me to change these numbers. So if I wanted to pull the first record of the first record and I want the ID, we're going to see if this looks, because I haven't looked at it to know if it has it. It did work. And in this case, the ID is actually the same because it's probably corresponding to the same class or course. So if we were to pull instead the user modified, you can see that that one is that date. And the user modified of, make another one. The user modified of the first record of data, the second record of what we call data 2, and then the user modified field. These two should be different dates. And you'll notice that they are. The one was on 10/18, the other one was on 8/27. Okay, so now that we've kind of went down the rabbit hole a little bit on how to navigate this, let's look at a better way of viewing this initial nasty data, just so that you can see it a little bit better so you don't have to necessarily do what we did in throwing them into individual variables to kind of understand what you're doing. So one of the easiest things to do is take your dictionary or your list of lists or whatever it is that's essentially a JSON dictionary, and we're going to do JSON dumps. And instead of just doing JSON dumps, if you provide it with the JSON data and then you provide the variable indent, and I find 4 to be a nice margin for easily human readable, able to see the indents. You can make this less or more as you see fit. If we run this, you can see that now it's in a tabbed over, entered down, easier to see how the nesting works, right? So we've got initially a list, which is where this one comes in. Then we've got a list, which is where this comes in. Then we've got a dictionary that has some specific entries, one of which is the user modified field, right? If I was to instead here, because now that we can see this better, put in the user key here, this should return us a dictionary and not a individual value. And you can see that it does, right? So this returns the curly brackets, let us know that this is a dictionary. This returns information about the user. The user has all of these particular fields associated with them. Let's just say that I want to pull out the name of that user. I can just add in name for the key, which again is on the left side of the colon. And now we print it, and now it's Vinith. And then if I was to remove this back, we can see that again, and we could pull in a different field, right? So we could pull in the display name. Okay. And if we wanted to select a different review, we could just change this number. So let's return the third review, since everything starts off at 0, right? This would actually be the fourth review. I keep getting those confused, so you'll have to forgive me for that. We enter that down. You can tell that that is a different person's display name. If we wanted to see more information about the user, we could just do that, and now we can see more information about the user. Okay, And hopefully you can kind of see how you might want to nest these things together, how this information kind of flows. So now let's try and define, or at least take a stab at why we think they're using lists and why we think they're using dictionaries for the things that they're using them for, and then decide for our particular use case, how can we get things into a somewhat flat file or series of flat files just to make it easier for us to deal with things, right? So in this particular case, you can see that we have an overarching list. Now, as you can see, that list contains multiple entries before we even make it to a second version of that list, or a second entry in that list. And some of this is just because it's carrying over to different things. So my theory as to what's going on here with this big overarching list is that these are the individual pages. So the API is only going to return a certain number of reviews per page. And then most likely, once we hit the next entry in the list, it will go on to page 2. So let's even see if there is a second entry in the list. So to do that, we can see how long individual lists are. So if we do data and we just see how long it is, we can see that it is 9. So what that tells me is that there is 9 individual pages of data. So if we were to do data 0 and print that off, which is going to look nasty. Okay, that's 1. So now data 1, which is the second entry in that list, should look significantly different. Run that, and I can't really tell if that was different or not, but this one has Joseph Paul. If I go back to the first one, oops, helps if I put in a number there. Go back to the first one. Ooh, this one has Joseph Paul too. Okay. The third one. This one has Joseph Paul as well. So what this tells me is that this could also be that the API potentially was pulled incorrectly, and these might be just duplicate entries. So let's take a look and see if data 0 equals data 3. Equals. And so it does. And so let's see if entry 8 equals 1. It does. So what this leads me to believe is that we've got some duplicate entries, and that tells me that there is some cleanup that needs to be done to understand better what's potentially going on there. So how I'm reading this is that this first entry we can basically just ignore because every single other entry after it is a duplicate, at least for right now, for this particular record that we're looking at, right? So really, we only need to loop over the second element in the list. So right away, the easiest thing that my opinion would be to do is to basically do so now, instead of looking at data, we're just going to look at the data that you care about, which is just the first entry in that list. So now if we take data you care about, and we know that this is a list too, and we take the first entry in that list, okay, there's a name, okay? And if we take the second entry in the list, there's a different name. And if we take the fifth, sixth, technically, entry in that list, there's a different name. Okay, and so we want to simplify this content. So right now, this is good because we can potentially loop over each one of these and then get the information that we want. But there's still some nesting going on. So we need to decide what we want to do about this nested information. And in this particular case, since this is a nest of just another dictionary, it's probably easier to just ourselves unnest it and put it into something else. So in this particular case, we're going to loop over every single element in the list, every single row of this particular set of data that I care about. So we're going to do for review in data I care about. And for right now, we're just going to print things so that we can see what's going on. And then also for testing purposes, I'm going to set up a counter temporarily. And if I is greater than or equal to 3, then we're going to break, which will break us out of the for loop. So what we want to do is I want to print particular things here. So right now, just to see what it's doing, we're just going to print the reviews. And then to separate the reviews, for me to be easy to see what's going on, I'm just going to print this. And if statement needs a colon, boom. Okay, there we go. We can see, ooh, it seemed to have looped over way more than this, which is because I forgot to do this. So now if we do it, it's just the first 3 records in the list just to make it easy for me to see what's going on, right? Okay, I do care about the ID, so we're going to do that. We're going to print the ID, the review, and then we're going to get the key, which will be ID in this case. And what else do we want to print? We also want to print probably the content and the rating for now. We'll see if we want other information too, but for right now, the other things that we want are going to be content and rating. Okay, and let's just see what that looks like. And let's not print the review for now. So now you can see it's printing the ID and it's printing the rating. And we could even list off other things here. Let's go back and let's hide that so that we know that we're calling that out correctly. Okay, now let's go back up and look at this one. So the user information is nested here. So what we want to do next is we want to pull that information out. So review and user. So let's just see what that looks like, and let's comment out the total review again. Okay, so user is a dictionary. It has a class, which is called user. It has a title. It has a name. It has a display name. Okay, let's just pull out, in our particular case, the display name, because that's probably all that we really care about right now. So we can print review user, and since it's a nested dictionary and not a list, it's just going to be another key, which will be the display name. So let's comment out that one. Now we can see that it's just doing the display name. Okay, let's do one more field from the user, and let's get the title. We're going to, actually, let's get the name, because that's different than what the title and the display name are showing up. So we're going to get the name as well. So let's print the review, and we're going to call this user, because we're in the user, and then within user, we want the name. Okay, and so we're going to get, boom, the display name, and then the name, display name, and name. Okay, so now let's get this into more of a flat context situation. So these are all the fields that I want, right? So easiest way to potentially do this to make it easy for pandas is we're going to just turn this into a list of dictionaries, which is, to me, the most logical, easiest way to view this and deal with pandas. So we're going to make a new list, and this is going to be our flat list, which is just going to be an empty list. And what we want to do is we want to do flat list, and we want to append new records into it. And what we're going to append actually will be a dictionary. So I want to append an ID. We're going to grab the ID field. And I'm going to assume that this particular ID is actually the course ID. So I could be wrong about this, and this is something that you would have to find out yourself, but we're going to rename this to make more sense. So we're going to call this the course ID, and we're going to give it the value of the review ID. Okay, and then the next item in the dictionary that I want will be the content. So we are going to call this review content. Will be from review content. And then the next thing that we want is the rating. Review rating. And then these are technically nested, right? But we're unnesting them. So we're just going to put the person's display name. And then we're going to put the person's name. Okay, and I'm going to keep the limit on it so then we can see what this flat list looks like at the end. So if we run this again, it ran through three things. We still did our print statements, but we should now have a variable called flat list that has stuff in it. And it does. And at least for now, it's easy enough to read. However, you could still do this little JSON dumps trick that we did. And we could feed in that flat list, and then it will print it off nicely with the 4 tab indents for us. And we can see that we've taken the nested structure that it was before, and we've unnested it to where it's just a list of dictionaries. And then we've also only picked the specific columns right now that we care about, right? Okay, so now the next piece would be, let's remove the limit on this and run it for everything. However, one of the other things that we may want to do in this case is we might want to do filtering here before we even get it into the list. So if we're going to be doing any information off of the individual review text, we may only want information that actually has reviews in it, right? So we might literally do a if statement here, and if this is not equal to blank, then we'll append it. Otherwise, we won't. So let's remove this and let's see if this actually works. Oh, let's remove the print statements as well here. And let's add a print statement here to just say added to list. Okay, so there was definitely some records added to the list. So now let's take a look at flat list. Okay, and let's look at it a little bit nicer, potentially even. Okay, and we can see that now only stuff that has entries in the review content is actually showing up in our list, right? Okay, The next piece will be, now that we've got a flat table that has our specific fields that we're looking for in an easy to read dictionary that's just a list of flat dictionaries. There's minimal nesting here because we just have a list of dictionaries. This is in perfect condition, ready to load into a pandas data frame just to make it easier to do more manipulation there. Doing more manipulation here probably isn't worth it. It's just easier to load it into a pandas data frame at this time. So that will be the next thing that we do. Okay, there is multiple ways to load data from a JSON list into pandas data frames, but I think the shortest one, at least textually, is just to basically define a new data frame and call the pandas that we've imported as PD, call data frame, and then from records, RECORDS, and then we're going to list in our list of dictionaries, which in this case is flat list. Boom. Run that, see what we screwed up. Data fame. Apparently we're famous. Okay, data frame, there we go. Okay, and now you get the easy to use, understandable pandas formatting for this stuff to where we've got column names with values that make sense. No nesting involved here, and then we can decide what we want to do with this for more filtering or alteration or whatever comes next. Now, the next thing that I'm going to do is, let's say that there are multiple files here. How do we deal with getting multiple files in? And maybe even using part of the file name as your potential input, or using some other higher level version of what we're looking at is a form of input. Really just dealing with how to get specific pandas and specific pieces up or down, not pandas, but specific elements in the JSON, either upstream or downstream, can be a little bit confusing. So let's take a look at that piece. Okay, now that we've thoroughly confused you all and have made this way more complicated than what it should be, Glob lets you do pattern matching. So in this case, in the same file where this Jupyter notebook is, we have a series of 3 specific JSON files, and we're basically using Glob to get where those files are physically located so that we can loop through each one of those files, open it up, and do basically all the stuff that we figured out above. So if I run that and I realize that I reset this, so I need to come up here and bring back in my requisites. Now if I run it again and we take a look at what this is, so we've got a list of 3 JSON files that are coming in and loaded up through Glob. So Glob let us grab all of the files that are labeled as just JSON. Okay, next I'm going to make an overarching list of all of the reviews, and we're just going to assume that we're going to dump all of the reviews into a data frame. Whether or not this is the right approach or not is something that you kind of have to figure out at what level you're going to put something in. And potentially, depending on how long this runs, you may want to make kind of like backup copies or incremental versions of the reviews or whatever it is you're dealing with. And you could kind of see that in some of the API videos that we did as well. So I'm making an overarching list that will be a list of dictionaries, just like what we had before. That's all reviews. And then I'm going to loop through each one of the physical files here, these 3 files, and we're going to do something with those 3 files. So the first thing that I'm doing, and this is just kind of a way to show that you could have very high-arching variables or potentially pull something out like an ID out of a higher level part of the JSON file and just store it as a variable up higher before you even get into the looping, because you want that particular variable to be stored with every single record. So in this case, I'm just getting the file name of the physical file that we're loading it from, and I want that as a column in every single one of the records that we're going to be writing into a data frame. Okay, next we're opening up a specific file, right? So we're looping over all the files. We're opening up the first one that we come to, the second one, the third one, and we're dumping it into a JSON object, which will turn it into a dictionary or a list for Python that Python knows how to deal with. So that's what this JSON loads does, gets us into the data we care about. Okay, the next piece, and this is where you've got to figure out up above, that was all the data wrangling and exploring that we did of the JSON files, is we have to understand what we're doing here. So I have a for statement here, and the for statement corresponds to the fact that this is a list, and it's a list of objects. So it's something that we can easily loop over. So if we go back up and let's load our one of our example JSON files back up, and let's print it off pretty for us with the indents. And let's scroll all the way up to the top. So we can see that this first one, because it's a bracket, is a list. And what we kind of determined before, even though it didn't quite work with this particular one, is most likely this first list is pages. And so we're going to loop over each individual list of pages, and each page is full of a list of individual reviews. And each review has particular attributes that are in a dictionary that are like the actual content of the review, the rating of the review, when that review was created. And each review is made by a user, but that user has individual attributes associated with it that are a subsection of user, right? It is a user is storing a dictionary, and that user has things like title and name in it. And so we kind of determined all of that. So when I'm dealing with key value pairs, I have to call out individual keys to identify them. When I'm dealing with lists or arrays of objects, I can just loop over them with the normal Python method of for and loop over them. And if you want to loop over them and know which particular element you're on, whether you're on the first element or the 100th element, you can use enumerate. So let's scroll back down and look at what we've got here. So in this first one where I'm looping through the pages, I'm enumerating over the data we care about. So what that lets me do is get a incremental counter as well as all of the individual reviews on that page, which is a list of multiple reviews, right? So that's what this is. So next, we want to loop through each review and all of the reviews on that particular page. Now, once we're down this far, we're no longer into list territory. So next, we basically need the key value pairs of the specific attributes that we want to store in our final data set. In your case, depending on what you're looking at, you may have to actually go into a dictionary, and then once you're into that dictionary, you might have to loop through particular things within that dictionary. Didn't really show you how to do that here, but you can kind of figure out how to do that with that first part that we were doing, where we were defining list elements with their numbers inside the brackets, and then key elements within their names within the brackets. So in this particular case here, we want the review, we want the content, we want the rating, and then this is a nested one, right? To where within the user particular key, I want his display name or her display name. And within the user key, I want the name of that user. And we're basically moving that all up into one flat table so it's not nested dictionaries like it currently is being stored as. The other two pieces of information that are higher level and higher loops up here are page count. So every single review within that same page will get the same page count number, and all of the reviews within each one of these three files will get its file name associated with it. And then the final piece here is just, in case you run this and it seems to be running forever, it will print off what page you're on and what file you're on just for your visual understanding. Most likely this will go too fast to even see that, but we're just going to see what it looks like. So if we run this, it did take a little while, so we might have been able to see these entries show up on the list. It goes through and it basically loops through all the pages of each one of the files and all the reviews. So now if I load that into a data frame like we did before, we should be able to see here is a data frame that has the file name, the page number that you were on, the particular course ID that you were working on, the review content, because in this case I didn't eliminate the blank reviews, so all the reviews are showing up. Then we have the rating, the display names, and the particular usernames that are associated with that, and then this goes all the way through. If we just want to look at a sample of, let's say, 15, let's do 15, and let's see what that looks like. So here's a random sample of 15, and all of these are ironically from the same file, but that's because one of the files was way bigger than the other ones. We can see that there's multiple page numbers, right? Multiple different course IDs within this, and then we've got different ratings and all of that. And this may not actually be the course ID. I was just making that assumption when I originally created this, but this shows you how you can then get it into a pandas data frame. So I'm hoping that that makes sense. I know dealing with nested information is really hard to deal with. But I will say that your better bet might be if this looping thing that I didn't do didn't make sense, you might just be better off making multiple variables and dealing with it that way, to where you just take a subsection, put it into a variable so you can call it back later, and then just deal with it at a smaller sub-level to where you're just dealing with the nesting yourself, one nested level at a time, one key at a time. It can be kind of painful, but once you get used to it, you'll understand kind of how to interact with the nesting and the particular pieces of how that all works. Again, for visualization pieces, if you have a JSON file, loading it up in Firefox will help you kind of navigate down through it with those arrows. If you don't want to do it that way, this JSON dumps with an indent as a variable will help out a lot. And if you wanted to save something from Python, including this indent function will actually put that into the file itself when you do a JSON dump. So that's another thing that you can consider. Okay, I hope that helps. And I know we've had some issues in the past with trying to understand that nested level of lists and dictionaries. So yeah, awesome. Thank you for your time.